engineering in ITB Bandung, and then he continued study his master degree in Department of Mining Engineering, McGill University in Canada, and then get doctoral degree from RWTH Aachen, Germany, major in management and economics of coal resources. So I think Mr. Wibowo, you can start your presentation.
Okay, thank you very much. I will share my screen, please.
Okay, that's good.
Okay, can you see my screen right now?
Okay, okay, sir.
Okay.
Good.
So the allocation times for me is 15 minutes. How many minutes?
You have
Moderator?
30 minutes to present it, and then there are 50 minutes in question and answer session, sir.
Oh, 15 and 15.
13 and 15 minutes.
13 and 15.
Yeah.
Okay.
30.
Okay. I have plenty of time, but I think I don't have so much slides. Anyway, start the presentation. Bismillahirrahmanirrahim. Ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, healthy greetings for all of us, and have a happy day. This afternoon, I'd like to share with you the development of coal utilization in our country. In the near future, coal is not only contribute to our energy needs in the form of primary energy source to generate electricity, but also as a more environmentally friendly energy source and source for non-energy sector. Before going further, I would like to convey several factors that underlie changes in coal use, which I've actually already started. First of all, of course, we have to refer to the energy mix that has been set by the government. In the year of 2025, as we can see in the upper right slide, the portion of new energy and renewable energy and energy mix is around 23%. Petroleum still has contributions of around 25%. Coal has the biggest contributions, at least 30%. And the last 22% is for gas contributions. However, for the energy mix in 2050, the contributions of coal in energy mix will be reduced to around just 25%, as well as portion of petroleum from 25% to 20%, whereas the contributions of new and renewable energy source and natural gas increasing to 31% for renewable energy source and 24% for the gas, natural gas. The second factor is the fact that the growth of domestic coal consumption is relatively slower than the national production rate. We can see later on the next slides. It means that our coal production is still export oriented, where in a pandemic situation like now, the export coal is less conducive. The demand for coal from Indonesia is reducing. So derivative products from coal are expected to become a new paradigm for the Indonesian coal mining industry. The export value of these products is increasing. As an example, from coal to methanol will increase the export value around 2.4 times. From coal to dimethyl ether will increase the export value around 1.85 times. In government regulation number 79/2014, it is stated that the priority of the use of coal is to meet domestic needs. It also stated that the added value of coal must be increased through gasification and liquefaction. This slide shows you the distributions of coal resources and reserves throughout Indonesia. The biggest coal deposit is located in Kalimantan, 62.11%, or around 62% of the total deposit, followed by Sumatra, around 38%. Coal also found in some other islands in Indonesia, in a small number. In total, we have around 149 billion tons of coal resources and 37.5 billion tons of coal reserves. So there's a difference between resources and reserves. Normally, we mine coal when we have already coal reserves, not coal resources. Based on its calorific value, Indonesian coal is mainly categorized as medium calorie, followed by low calorie, high calorie, and very high calorie respectively. You can see the number, the percentage number in the pie chart in this slide. This slide, slide number 4, gives us information about Indonesian coal production from 2015 until 2020 in the month of August. The production has reached its peak in 2019, around 616 million tons. The coal production in 2020 is planned to be 550 million tons. However, due to pandemic, until August 2020, the realization of coal production reached 362 million tons, 11% lower than production at the same period in 2019. Pandemic has been causing an impact on the coal mining sector. The decline in production is related to decreasing demand from countries of export destination, the coal price becoming low. And for mining companies and mining logistic companies, they are experiencing difficulties in limited access and mobility. In terms of export, in this slide, up to July 2020, coal export declined by 11% compared to realization of coal export in July 2019, 238 million tons in 2020 versus 266 million tons in 2019. This has happened because India, our main export destination country, reduced its coal demand by 20%, as well as South Korea, which reduced the demand of coal by 15%. Another factor is related to the policies of major coal importing countries, such as India and China, which prioritizes the use of domestic coal. Domestically, coal consumption in 2020 has declined mainly due to the decrease in coal consumption by PT PLN, the state-owned electricity company. This year, PT PLN is estimated to consume around 95.6 million tons of coal. As you can see from the figure at the below of the slide, the electricity sector, or PLN, consumes the biggest portion of coal. Now we are talking about the security of coal resources. Talking about the resilience of our coal deposit, this graphic shows the estimated coal production and coal reserves. The blue bar chart is coal production, and the orange one is the curve for our coal reserves. With a production rate of around 600 million tons per year, Indonesia's coal reserves can still be utilized for more than 60 years. So actually, we have still have a lot of coal reserves in Indonesia. coal is still main mining commodity in the non-petroleum and gas subsector. As we can see further on, we can see then the utilization, the extended utilization of coal beside, other than as a primary energy factor. Yeah. In this slide, we can see that considering that we have enough coal resources for years ahead, it is time for us to change or extend the utilization of coal, not only for primary energy source, but also the utilization of coal to support non-energy sector. As we can see from the this slide, yeah, the domestic coal consumption is reduced in this year, yeah, just 73 million tons by July 2020. So if the estimated production, the estimated coal production is reached at the end of this year, then there is a lot of unused coal production will be increased. Okay. In this slide, I'd like to share some reasons why we have to extend the utilization of coal, which is known as downstreaming of coal, or hilirisasi batubara in Bahasa Indonesia. There are several argumentations that support coal conversion to products other than electricity. For example, the first one is that we have the fact that we have large coal resources and reserves. The fact that starting this year, and we have unused coal production that will be increased in the years ahead. And also we we can use coal derivative products that can substitute the petroleum, the BBM, the bahan bakar minyak and gas, as well as raw materials for chemical industries and others, reducing the environmental impact or the economic value, and etc. The objective of the coal conversions are reducing imports and increasing energy security. This is the first one, because with coal conversion we can substitute, for example, LPG with DME, means that we can reduce our imports of our LPG imports, and maybe can save some money, some revenue for the government. The second one is increasing added value, or increasing value added, coal utilization development, coal conversion through various products, both energy products or non-energy products. And the third objective with this downstreaming of coal is that we have to reduce the carbon monoxide emissions. In this slide, just show you diagrammatically the utilization of coal, both as an energy products and non-energy products. As we can see, coal is not only served as a primary energy source. There are a lot of products that can be derived from coal through several processes, namely coal gasification, that is the first one, coal upgrading, and maybe I can use my, oops. The first one is coal gasification, the process, we call it. The second one is coal upgrading, and then coke making, and then advanced coal carbon materials. This process, this process produces various kinds of energy products, such as hydrogen on the right-hand side of this slide, methanol, biodiesel, methyl ethyl, and high quality coal. These products here, this 1, 2, 3, 4, 5 products is included, or we call it as an energy products. On the other hand, coal conversion of coal can also produce non-energy products such as ammonia, urea, semi-coke or carbon precursor, coal tar pitch, and also carbon precursor. We can see now the coal gasification, because this is the primary objective of the downstreaming coal downstreaming. There are some reasons why we convert coal through gasification to produce syngas, hydrogen, methanol, and the methyl ethyl. The reason is the arguments is in the left side of this slide. Yeah, the first one is that we have the quite large potential for low calorie coal. Low calorie coal normally cannot market easily because they only have low calorie, of course, and the mining for low calorie coal is very expensive then. So in fact, we have 10.9 million tons, or around 28.9% of total reserves, categorized as low calorie, in which the conversion of coal can be applied for this type of coal. The second argument, or second reasons for gasification, is that the added value of the derivative product is high, 2 to 3 times of the coal price, for example. And then methanol. Methanol can be used as a mixture for biodiesel. So in collaboration with other industry, coal can be used as a or can produce a biodiesel. Another product is the DME, the methyl ethyl. This product can substitute for LPG. And if we can substitute DME, if we can substitute LPG with DME, then we can reduce the revenue that we have to pay for export the LPG. The substitution of DME for LPG can reduce Indonesia's energy imports by 40 trillion rupiah. In this table, the small table in the middle of the slide, we can see that the comparison between DME, the product of DME, and the LPG, the propane product, from the chemical formula, boiling point, and etc. But the important thing is that the net calorific value of DME is smaller than the net calorific value of LPG. The DME is only have 6,900 kilocalorie, while the LPG, the calorie is more than 11,000 calorie. Yeah. And the diagram here just shows you that the number of absorbed coal production estimated, of course, from 2020 to 2020 to 2050. So we can see that the amount of unabsorbed coal production is increasing rapidly. So that's why we have to do something in order to utilize this unabsorbed coal production through the conversion of coal, especially the low and medium calorie. Okay, then in this last slide, I just show you the table about the development of coal utilization until now in Indonesia in terms of product, technology, and challenge that we faced. For example, if we convert the coal through the DME and methanol, We already have the technology, that is gasification, but the challenge is the investment is very high, and the ME price must be able to compete the LPG price. Or this one, for example, if the product is semi-cokes or carbon razors, the technology is carbonization. We also have that technology, but the challenge is market is very limited to the use of smelters with RKEF technology. So this carbon razor semi-cokes is only used to smelters that using process called RKEF. For urea and ammonia, the technology is gasification. Investment is also high, like the ME and methanol. Syngas, for example, the technology is also there in gasification, but the challenge is syngas still giving us negative environmental impacts, yeah, and domestic technology has not been proven. And also we have a high quality coal. This is just coal upgrading. This is the old technology, but the upgrading technology is not yet commercially proven until now, even though it is already developed long time ago. The recent technology, the challenge is it is necessary to integrate upgrading technology with CFPP, coal-fired power plant, or other technologies to make it commercially viable. For the advanced carbon material, this is the technology is distillation. This technology is not yet commercial, still in the R&D stage. And for the last product, hydrogen, for example, this is resulted from gasification. The market doesn't exist yet, then the infrastructure need to be built. From this table, from various products in this downstreaming coal, we see that there are still many challenges that we have to solve if we want to be a success in conversion of coal. So I think this is my last slide. Thank you very much for your attention.
Yeah, give applause to Mr. Wibowo. Thank you, sir. So let me share some review and the key point from Mr. Wibowo presentation. Mr. Wibowo begin by give us information about Indonesian coal resources and reserve. And then he continue by sharing to us about information about coal export of Indonesia, and then the security of coal reserve, then the reason for downstreaming of coal, yeah, and also about utilization of coal on an energy and non-energy sources. And this is the very important information, I think. How about the coal to gasification process? I think this is a sexy field today. So we can give added value for the coal, because if we just sell the raw coal, it is a very cheap price, I think. And when we making a goal to gasification process, we can get the added value from the coal. And then Mr. Prabowo tell us about development of coal utilization. Okay, thank you, Mr. Prabowo, for your presentation. You have still about 10 minutes, sir. How about or just we going to the next subsection about a quick question and answer, or you want to share another information maybe, sir?
Oh, because at the beginning I just informed that the presentation is only around 15 minutes, so
Okay, sir.
just prepare not many slides. But
Okay.
well, we can. I think this will be better if you can discuss if there is a question about the coal utilization.
Okay, thank you. So, for the all participants, let's begin our discussion. Maybe this section you can make question to Mr. Wibowo, or maybe participant want to share maybe information or something related to our topics. So I give all participants to make question. You can make question by text in the chat room, I think. Okay, anybody want to make question? Yeah, to all the participants, you can text your question in the chat room, and I will tell Mr. Prabowo about the question. So now we are waiting for the question from the all participants, because we have about 15 to 20 minutes in the question and answer section, so we can use this to make or to discuss if the participant want to discuss something with Mr. Wibowo, you can share the question, and maybe Mr. Prabowo can share with us his expertise in this field. Okay, I think meanwhile we waiting for the question from the participant, I want talking with Mr. Wibowo. So, Mr. Wibowo, you have expertise in the coal utilization, and also you are head of one of, I think, research head of one of ITB Research Center, I think, in economical, I don't
Policy and economics of minerals and.
Can you share with us with what is your current research in the field of coal utilization? Maybe you can share with us your expertise in that field, and also how the future about coal utilization, because we know that fuel energy, they are decreasing in the demand of coal, and we know that like in the automotive era, so the electric car will be produced by manufacturer maybe in the five years from now. So we will no longer need fuel or fossil fuel replacing with the battery. So how to handle this situation? So how the coal or using like coal utilization, it still can give maybe big money for our country.
Okay, thank you very much for the question. Well, actually, my research center is not nothing to do with the coal utilization directly. Our research is doing policy and economic research about the mining industries. But in terms of coal, I think the future of coal in Indonesia is still bright, as you can see from one of my slides, we still have a very big, I mean, the amount of coal resource until 2050 in my graphics is still more than 25 billion tons. So if we maintain our production, coal production in the rate of 550 million tons, then we still have more than 60 years of coal deposits. And if we can extend or if we intensify our exploration in finding coal, then it is probably we still have more. My estimation is we still have a coal deposit that we can utilize for maybe 100 years ahead. So still, coal is very, very important. And as an energy, as you can see, until now, the around 60% of PLN, generating electricity by PLN, is using coal. They didn't use any more oil, petroleum, and gas. And the contributions of renewable source energy is still small in portion. PLN have a PLTA, water, what you call it, pembangkit listrik tenaga air, but the number is also not significant. The usage of coal in PLN in generating electricity is still the main fuel. Yeah, I mean, so on the other hand, the development of the renewable energy, I think, sorry to say, or honestly, we still have a very slow development in renewable energy. So my prediction is the importance of coal in our country will be significant in the future, still significant in the future years. And the new program from the government, also in the last week rapat terbatas of our president, the president wants us to what do you call it? Not increasing, but get it to to increase the pace, of the roadmap of downstream coal downstreaming. So in the next future, coal will have another role, another contributions, not only as a primary energy source, but also as a production. Yeah, we can call it like that. Coal will have contribute to the with other materials to produce gas, for example, to produce methanol, dimethyl ethyl, and etc. Also non-energy products, as I mentioned in my slide, ammonia, for example, or tar. Yeah. These products in the future, if we are serious to develop this industry, this industry, the heater industry, we call it in English. But this product will be give Indonesia a very good contributions in terms of economic growth. Because with DME and syngas and also hydrogen or also methanol, we can produce another product in the downstream. And I think related to the our wish to move from the developing countries into the developed countries, this program is very, very important. So I think that is my answer.
Yeah, thank you, sir. And how about the maybe environmental issue? So, because as we know that producing coal will make effect to the environmental. You can correct me if I'm wrong. So like in Borneo or in Kalimantan, we can see that there are so many coal mining there, and maybe can make environmental issue. How about this effect for our environmental? Can you share with us? Does coal still safe with our environmental?
Okay, good. Environmental is our biggest problem actually, because as a miners, I am a miner. We have to damage the environment. We have to damage the morphology in order to get the coal, for example. Similar with other mineral deposits. But in we have in mineral industry, we have a conduct called good mining practices. So from A to Z, from exploration until to the marketing the product, there is a guidance, there is a procedures, there is a what you call it, a code of conduct, how to dig, how to mine the coal from the earth. Of course, we have to at the first time. Of course, we have to open the. We have to damage the what you call the surface. But after that, especially in coal, yeah, coal the opening of coal mining is not big, because we have to mine coal in a sequence, and every sequence involves just small area. So as we move from one area to another area, the first area that we have already mined the coal, we have to directly have to reclaim it, that area. So the reclamation will be done in coincidence with the next level, next block, next area that we want to mine the coal. So this sequence continue until we already have all of the coal deposit. So in terms of in the mining sector, in the coal mining, we have methods, we have guidance how to protect the environment, including if there is a potential of acid mine drainage. This is very dangerous for the for the area. So we have already the technology, and we have to do the what you call it, the protection, yeah, so that the acid mine drainage is not happen in our coal mining. The problem is now if that's right that in media we saw that the environment is damaged by the mining, but we have to be careful to see that which kind of mining is that, because there are a lot of illegal mining also in coal sector. This illegal mining doesn't apply the good mining practices. So most of the environmental related problem that we found in the site is caused by the illegal minings, or because if mining company that has already izin usaha pertambangan permit for mining, they will controlled by the government. So I think if the problem is there, you are right. The problem is there. The environment problem is there, and we have to do something. But we are not just the what I mean with we is not just the mining people, miners, but also the stakeholders, the other stakeholders. yeah, including the illegal mining. If they stop the activities, then I think the environmental damage will be reduced significantly. So I'm still optimistic that coal will give us a welfare and will give enough revenue to the government, yeah, especially when we downstreaming the coal. I think like that, yeah.
Thank you, Mr. Wibo. And there are another interesting topics based on your presentation. How we say coal gasification. How about this, sir? How about the price or is that the price by using coal gasification? It can compete with another like LNG from LNG, liquid natural gas. If we compare the price in coal gasification compared to the price from the LNG sector, does it compete or it can compete with in the price with the LNG sector? Right?
Yes, you're right. That as I mentioned also in the table in the last slide, that we still have to make sure that the DME price can compete with the LPG price, especially because of the calorific value of DME is smaller. It's only half from the half of the calorific value of LPG. So means that we need more DME to produce the same calorie compared to LPG. But I think the technology right now is focusing our aiming or reaching reducing in cost to produce the DME. I also mentioned the what you call it, the advantage of government if we can substitute the LPG with the ME. So at least there's also expenses for buying or producing the ME, but it happened in our country, not export LPG from other countries. So at least that is the advantage. But I think I'm optimistic that the cost of producing the ME will be reduced.
Thank you, sir. And I think this is. Yep. Oh yeah, Mr. Professor.
Yeah.
Okay, sir. You can
Thank
make
you.
the question.
My pleasure.
Yeah, thank you, Mr. Johnny. Thank you, Pak Ari. Yeah, Pak Ari, interesting for me. I'm not the guy, the person who have research on the coal, but actually I have several work about emission reduction. Yeah, and of course you already mentioned about that. In our discussion, we keep calling that if our government want to reduce the emission, why don't we think to reduce our coal, coal reduction in our power production system? Yeah, so I just want to know your idea. Do you agree as an expert in the coal mining and etc.? Do you agree that Indonesia should, let I say, move, because we have the target in INDC, yeah, in INDC. So because our energy sector still increase, yeah, and I'm sure since, from your presentation you said that coal still promisingly, and also we still have resource for a couple, let's say 80 years. So I'm sure the coal will still be there. So about the statement, do you agree that if we want to meet the reduction target, we have to move from the coal in our power sector?
Sorry, the last statement I didn't hear you correctly.
Yeah.
If
I'm sorry. If Indonesia want to meet the target of emission reduction, yeah, do you think we have to reduce the coal from our power sector? Yeah, because there is two issues now in here, Mr. Ari. I don't know if you agree with me, because now we have, we have also like the power sector generation. Of course, you know about the super critical, so we can
Yes, right.
we can use coal more efficiently. But some of the idea said that we have to move the coal from our power sector. Which one should Indonesia take this in this strategy?
That's a good question. Yeah, Indonesia should do both of them. Increase the technology, increase the generating technology, generating electricity technology into the latest one. I think Japanese has the latest technology in supercritical power plant, and we also have to switch the utilization. Not switch actually, but the old one is still there. But we add another utilization of coal, not because of I didn't think even about the reduction of carbon emission. Actually, to be honest, I just thinking about that. It is pity that we have a lot of coal deposit, and our production is very high, and 70% of our production goes to export.
Yeah.
In this year, the pandemic is coming. The export demand is decreasing, but the production of coal is still there. I mean, the number of coal that we produce this year will be 550 million tons at the end of this year. That is the plan of the government, and it is the plan. Actually, the actual number is more than that, as we experienced from the last years. Yeah, but so that for the reason that we have a lot of coal, we still have a lot of coal, and with the production of our coal we cannot reduce immediately. I think the government planning to reduce the coal export in 2046, if I'm not mistaken. So in 2046, coal exports will be zero. You can imagine at that time the coal production will be around 440 million tons. Nowadays, the domestic coal utilization is only less than 200 million tons. Yeah. Not today. Today is, I think, less than that. Yeah, I mean, in 2025, 2030, it will be around 200 million tons. So there is a gap. There is around 440 minus 200 million tons. There's more than 200 million tons of coal that we produce every year unused. So what should we do? It is nothing to do with the CO2, my thought, yeah. But if in reality, of course, we have also follow the convention that Indonesia has ratificated. I mean, the CO2 reduction is already what you call it, harus kita laksanakan. We have to do that.
Yes, mandatory.
It's mandatory. It's mandatory for our government. So extension of utilization, coal utilization will be, we have to do that in order to absorb the delta, the excess of coal production. But I have to, regarding the coal-fired power plant or PLTU, as you also already mentioned, the technology is improving. And with coal gasification, we can also improve the process of electricity generating using IGCC, integrated gasification coal combined. So we are not using coal directly into the CFPP, but we convert the coal into the gas. Yeah, some of the gas, portion of the gas will be used as a power generating electricity. So I think this is this will reduce the CO2 emission also in the power plant so because Indonesia needs energy. And coal-fired power plant is one of the alternatives, best alternative now. I can say like that. So that is my opinion.
Okay, thank you, Pak Ari. My next question. I'm sorry, still at time, Pak Joni?
Yes, sir. We are still have time. We can make another question to Mr. Prabowo.
No, yeah, interesting to me because I saw also the slide of Pak Ari. It said like gasification and everything. It's not well proved, high, not yet market. My question, because like in Indonesian case, we use mainly the coal for the power plant. So it's not too expensive, do you think, if we try to convert it into gas?
Yes, okay, that's a good question. Of course, it will be expensive because the cheaper primary energy source is coal to generate electricity. Even water also still the cost is still higher than coal-fired power plant. But yeah, here we have to think now. We have to think about the how to reduce the coal emission. Yeah, then and I think if or maybe I don't know if Indonesia. I don't think that Indonesia has already CFPP with the supercritical technology. I think this is still too expensive for us. But IGCC, I think, is a good alternative. Yeah. So I mean, for the next AFPP, the government has to be regulated. That the next CFPP has to be built together with the gasification plant, for example, like that, so that it will be reduce the cost of the gas that we have to pay. Actually, I have a opinion about the business of the coal mining and PLN, for example. Yeah, I have a what you call it, usulan. What is usulan? That why there is no company in Indonesia, yeah, that we call it perusahaan energy company, like in Germany, for example, or in other country in Europe. So the energy company can produce my coal, yeah, and then directly use the coal into the electricity generation, so that the price of coal is just the production cost. The government doesn't need to tax this coal from the energy company. So energy company just pay the production coal without any other tax or royalty. And this energy company will use this coal into the to produce the electricity generation. Now, after that, if the company, if the government think that they need to tax this electricity generation from energy company, then it's up to the government. I mean, on the basis of energy, on the basis of electricity, not on the basis of the coal. So I think this type of company or badan usaha can reduce the price of coal in the electricity generating company. I think like that.
Okay. Thank you.
Thank you, Pari,
for your great
No
presentation
problem.
to us. And unfortunately, time is up, so we must go to the next speaker. So our second speaker is Professor Himsar Ambarita. Good afternoon, Professor.
Yeah, good afternoon.
So I will read the vitae of Professor Ambarita. Professor Himsar Ambarita, he graduated from USU, ya, Mechanical Engineering Department in 1997, and then he continue his master degree and get master degree from Mechanical Engineering Department, ITB, Bandung. And in 2007, he get Doctor of Engineering in Production and Information System Engineering in Muroran Institute of Technology, Japan. Currently, the position of Professor Ambarita is Head of Mechanical Engineering Graduate Program, USU. So now you can start your presentation, Professor, sharing with us your presentation, utilization of renewable and conventional energy in palm oil industry in Indonesia. You can start your presentation. Thank you.
Okay, thank you, Mr. Johnny, and thank you all of the audience, and my pleasure also to present with Pak Ari. Yeah, and I think, yeah, the chairman said that because we only two presenters in this session, we have more time. Yeah, sometimes in the presenting some of the research result in 30 minutes, it's very challenging. Yeah, but I will try my best. Yeah. Now we will talk about the utilization of the renewable and also conventional energy in the palm oil industry. Yeah, I don't know why how I say the panitia in Bahasa put me in this, but since my field
Organizer.
Yeah, the organizer, my field especially in renewable energy, yeah, but put in the conventional energy, but no problem, maybe because this industry is a good example moving from the conventional energy to full renewable energy, because palm oil industry in Indonesia is, we talk about the history, start from this province in Sumatera Utara. I do remember that when my child time, that palm oil industry fueled by conventional energy. They still use oil and everything, but now it is not. But we will see how much this industry consume conventional energy still. So today I will talk about the utilization of renewable energy and conventional energy in the palm oil industry of Indonesia. Yeah, I hope this presentation can be, the participation can be focused in this presentation because the time is very, how I say, it's like the boring time after lunch, and then this time should be coffee session, but now we talk about the serious problem. Okay, so first I would like, this is my outline, the presentation outline, introduction to Indonesian emission and also the renewable energy target, and then the palm oil industry, and then how the findings of this study, and then we go to the conclusion and recommendation. Yeah, as we know that Indonesian government always talk about the climate change. Yeah, the climate change milestones or the discussion about the climate change, it's already start in 2007 in this country. Yeah, we can find the document National Action Plan and developing planning response to the climate change in 2007. And after that, Indonesia keep participating in the area, in the discussion about the climate change in the United Nations organization. So in this, we have so many targets. The first target announced in 2009, yeah, about SBY president, Indonesia said that we have to reduce our emission 26%, yeah, in 2020, 25, sorry, by our own budget, and also we have additional to become 41% with international support. And then we submit our INDC target to UNFCCC in 2015. It says that 29% increase into 26% increase to 29. This is the second target. And we have to reach it in the 2030. And also recently, our government released RUEN, National Energy Planning. Yeah, in this target also, specifically we said we have to reduce the fossil fuel into renewable energy. This is the milestone of our regulation about the climate change. And this is our target. Yeah, this is the target Indonesian government submitted to UNFCCC. As we see, we should focus on the energy. Yeah, in the energy, we have to reduce in 1,355 million ton of CO2 equivalent. This is a big number. Yeah, and then CM1 means our own budget. CM2 means additional budget, support from international. So it's not only in energy, in the waste, industrial, agricultural, and forestry. So this number should be reached by Indonesian government. That's why, since RPJMN, I know from Bappenas that in the RPJMN, yeah, I don't know in English, Rencana Jangka Menengah, 5 years planning document. Before, in the planning document, we only knew indicator like mainly dominated by economy. Like, let us say in bahasa, angka kemiskinan, yeah, etc. But in this time, our RPJMN will be included how many emission Indonesia can reduce. So the emission will be similar with the economy indicator. What does that mean? It is mean that Indonesian government have to provide some budget to meet this target. So maybe if we are entrepreneur, we have to look how many company we can build to spend that kind of, because what I got the information, but in Bapenas, around 2% our budget goes to low emission development. So this is a big challenge, not only for academic, also for the enterprise, and also for all of Indonesian who has the company, how to meet that target, because our government already put that target in their PJMN, and because of that, they have to execute that, and they need support also from the other stakeholders. So this is the present energy consumption, the how I say share of the energy share, but this is the old data I can get in here. So mainly we still use around 5 to 10% our renewable energy, but the other is still from fossil fuel, and let's say oil, and also coal, and also gas. Yeah, it's very significant number. This is the target. What we can get from 2025, 2045, 2050 should be 31%. This is very big. This is very big. Not only because increasing in the percent, also increasing our energy use. If we use this year 100 with 23, it means only 23 renewable. So if in 2050, that's 100 become 1,000, it means 31% from 1,000. So this is a very big challenge. Yeah, this is a very big challenge. Not only the number of the percentage, and also the cumulative number. Even though we always said, yeah, I picked this data from the RUPTL or PLN. That's the planning of the electricity in Indonesia. We said that we have many potential: water, geothermal, bioenergy, solar, wind, ocean, shale gas, and also CBM. But what I say, the right column, it's only very low, 5.3, 4.8, 5.4. But we want to increase this to 31. Yeah, that's a very big challenge. So let's say what now energy used in the palm oil industry. Yeah, I think the moderator also have business in the palm oil mill, so maybe he can also comment in this data. Yeah, the palm oil industry, even we now celebrate 100 years of ITB, the palm oil industry is more than 100. So the palm oil is older than ITB itself. Yeah, and also in 2016, the data is said the total export is 28.1 billion USD. It's very big money. And can you remember this 1,731 companies in 25 provinces get involved in the palm oil industry in Indonesia. And also this sector absorbing 60.2 million of workers. So many people work. Can we imagine from 260 of Indonesian population, it's around 60 million people, yeah, work in the palm oil industry. So we have to save this industry. So in this present work, I do research how to know the characteristic energy utilization in the palm oil industry. And we estimate again the potential of renewable energy from the waste of the palm oil industry. I think the keynote speaker today from Sweden, they talk about the biogas production in Indonesia. Yeah, that's very interesting because we know the potential is a lot, but why it is not success yet go into the grid. So the method I use in here, the study, literature review, and site visit, and I did some interview with the consultant who have business with the palm oil industry. So this is one of site visit I did in this industry, as we see. Yeah, this is maybe a dirty industry. I don't know. Yeah, of course, not so like industry we can imagine, but this is so many, yeah, process in here incorporated with engine, chemical, and also physical and everything. So what is in here? This is the lorry, yeah, before we enter into the sterilizer. This is the steam, yeah, blow down, and also this is the waste, yeah, empty fruit bunches, ya, tandan kosong in bahasa. So this is the development of the palm oil industry in Indonesia. Even though the Europe said that this is not environmentally industry, but still the industry is growing very fast in Indonesia. In the left hand of this graph with the blue mark, it is the area of the palm oil increase, yeah, in the last 10 years from 2010 and 2020. Yeah, of course, the production also increased in the 10 years, not only in the size, in the productivity also. Indonesia it's getting better. In the right side, I make a graph how many, how many ton of CPO can be produced per 1 hectare of the palm oil in Indonesia. So if the number increase, it means the people to trade or the engineer, how they develop the palm oil efficiency is better. Yeah. So what I want to say in this graph are 2 points. The first one, the industry increase in number, but also the industry increase in terms of efficiency. Yeah, bigger and also more efficient. That's a good point. So it means our government and all those researchers work hard in this industry. Yeah, it is. I think it's a good because this is also the main income for Indonesia. So, and also I get the information. Palm oil mill in Indonesia increased very fast. When I start to study the palm oil, I think in 2016, I only get number, it is around 700 palm oil mill in Indonesia. And also in today's presentation, I think Mr. Oka, Professor Oka from King Fahd said around 700. Yeah, it is the data 4 years ago. But now I get it is already 1,094 palm oil mill in Indonesia. And in the world, it is 1,879. So almost all of the palm oil mills placed in Indonesia, mainly in Sumatra Islands and also in Kalimantan or Borneo Islands, some also in Malaysia. Okay, this is to make like illustration what they do in the palm oil industry. I try to show you some picture. This is the fresh fruit branch. They put it in the lorry. They call it lorry, and then they send it to the sterilizer. And then this is the main product, yeah, palm oil, or we call it CPO. And this is also side product, palm nut shell. Yeah, Pak Ari, the heating value of this waste comparable with the coal. So the coal you study is comparable with this palm nut shell in here. And this is the empty fruit bunch. This is also waste. And also the most dangerous of waste is pome. palm oil meal effluent, because this waste can release methane gas to the atmosphere to make emission very bad, 21 times compared to the CO2 emission. So about the process in the industry, we also study from the one point to another point. So in here, they use a lot of energy. Mainly the energy produced from there's a power plant. Yeah, every palm oil mill has power plant in two objectives. One, to produce electricity to move all of the engine in here. The other is to produce steam used to make process in the palm oil bunches. And from this to threshing, from threshing result the waste, and then press station. From the press station will be divided into nut and then sludge, and then will be produced the CPO or crude palm oil, and then some waste go to the waste treatment. So the interesting thing in here, some of the waste they are sell from this station, and also fiber from here. They use it as a fuel, to the boiler. So in the beginning era of the palm oil industry, the fuel for boiler, they use fossil fuel. Some also use coal. So now they cut it, and then they use the waste from the cell and also from the fiber, and then they use it become fuel to the boiler. This is the typical energy in the palm oil mill. So, and then in this study, I tried to make survey. Not all, because I cannot visit 1,000 palm oil mill. I only pick some example. I just want to make sure that this number are true. So we make like analyze and also proven by the interview and also site visit. For every 1,000 kilogram of fresh fruit bunches that will produce main product CPO around 223, and then palm kernel oil, it is 46, and the other is the waste. It is empty fruit bunches 226, cell 55, and then mesocrop fiber is 140, and then the rest are pome. Pome is this effluent. So, and then from the interview, we make like how I say small FGD, and then empty fruit bunches, it is not reused. It's always sent to the field, become waste. But nuts, the cell, it is 50% reuse, become the fuel, and 50% still can be saved as a waste. And fiber, 100% used again, become a fuel. Pome, no. So this is the net of the waste from the palm oil mill in Indonesia. So I got this from survey, and also I validated it by some document. Okay, and then I try to look how many energy content in that waste, and also moisture content when they were put in the field. And then I compare the value with the coal, bituminous and lignite. Yeah, of course, this is the low level. Pak Ari maybe will comment this to this later. So what we can see is that from the cell, yeah, in here, the high heating value in megajoule, it's around 20. Yeah, of course, it is less than bituminous, but higher than lignite. And the empty fruit bunch, it is around 18.8. So based on this value, and then we try to compare it into ton oil equivalent. So from 1094 palm oil, yeah, waste, if we try to calculate the oil, the energy saving, if we count it into ton oil equivalent, from empty fruit bunch in this year, it will be around 524 million ton oil equivalent. Yeah, from cell around 36, and from pome it's around 647. Since we said that our palm oil industry will increase in 2030, we estimate the potential will be in total, 1.2 million ton oil equivalent. Even though we have so many potential, in here, so many potential, but surprisingly, from our survey, the conventional energy still used very, very big use. How I say, it's very, very big. Conventional energy are used in this. Why? Because, I'm sorry. I don't know what's happening. Okay, back again. There is a big number of the conventional energy still used in the palm oil industry. This is the main, the main used to the fossil fuel. One is for the office and housing to produce electricity, and also to transport the fresh fruit bunch from the field to the mill, and also to power the tractor and heavy machine, and also to power the palm oil mill itself. Because sometimes, if the fruit is not sufficient enough, they operate it with the diesel oil, the mill itself. So when we calculated it based on the interview and also some FGD, to the owner of the palm oil industry, they in every 12,000 hectare. Why we call it every 12,000 hectare? Because there is like a certain number. They said one palm oil mill, should should be operated in 12,000 hectare of planted palm area. This is like the like the norma. They said the norma number or the average number of the percent of the palm oil mill. So if we count in every hectares, this is the number of diesel fuel used in this industry. This is a very big number. Yeah, this is a very big number. This is per year. So our government should think how to reduce this consumption of the oil in this industry. It's still very huge number. Okay, and then the last, yeah, I will say this is how they reduce by emission in the palm oil biogas. So this is like the methodology developed by our government, because at the end we have to prove how many emission reduced by Indonesian to UNFCCC. So now in the Ministry of ESDM, they build some methodology how to calculate the emission from the palm oil mill if we install the biogas power plant. Okay, and then the final, I will make the conclusion from this study. Our conclusion in here, yeah, the first one, the total area of the palm planted area and produced CPO in Indonesia in the year 2020, it's very big, around 15 million hectare, and also the CPO produced, it's around 50 million ton of CPO. This is a very big number. Make Indonesia become the produce 61% of the palm oil in the world. And also the palm oil industry has abundant renewable energy potential, and then some of the potential already used in the CPO production. Yeah. However, the palm oil industry still use so many big of the fossil fuel, and yeah, it is estimated in 2020 around 602 million ton oil equivalent still used in this industry, conventional energy. And it is suggested that the palm oil industry has to replace the fossil fuel consumption by utilize its renewable energy potential. Okay, this is my presentation. Thank you. I'll give back to Mr. Johnny.
Yeah, thank you, Mr. Ambarita. And let's us give applause to Mr. Ambarita presentation. Okay, so I want to share some review or the key point from the presentation of Mr. Ambarita. So Mr. Ambarita begin with the give information to us about emission reduction. Yeah? The target is very interesting to us that in 2030, there are about 1,300 million ton CO2 reduction. I think this we must going to this target in 2030, and then he continue give us information about present energy consumption, and then target of renewable energy share. Yeah, based on Mr. Ambarita presentation, in 2050, the target is 31% of all energy will be using renewable energy. Well, I think this is sexy topics. In 2050, there will be 31% all energy will be using renewable energy. And then he give information to us about the potency of new and renewable energy. And this is also interesting fact that palm oil industry in Indonesia is gaining so much. Yeah. Now in 2016, yeah, there are about 1,700 company in 25 provinces in Indonesia, the palm oil mill, yeah? And there are about 16 million workers, yeah, working in the palm oil mill industry. And there are also another key points that the palm oil in Indonesia market share in the world is about 61%. I think this is a very good number. Yeah? 61% the market share of our palm oil mill in the world. It's also, Mr. Ambarita shared to us about the distribution of material in CPU production. There are any dangerous material like pome. So in process of 1,000 kilogram fresh fruit buns, they will produce about 650 kilogram pome, and it will become problem in our environmental. And then he also comparing between fossil fuel and the energy that we can get from the palm oil mill. Yeah? I think this is a very interesting topic, yeah, and I have also experience, yeah, in this field because I get many projects in the consultation of palm oil mill, especially in North Sumatra area. Yeah. We also have client in South Sumatra and also in Borneo or Kalimantan. So, like Mr. Ambarita said to us, there are like a magic number in the plantation area. Yeah, in about 12,000 hectare palm oil estate, it will need one palm oil mill with the capacity of about 30 ton FFB per hour, I think. Correct me if I'm wrong, sir. So, and there are interesting fact in palm oil mill industry that the industry or the factory doesn't need external sources of energy. It can self-defense. It can get the energy from the, I think, palm nut shell, yeah, and also from the mesok fiber. And in Sumatra and in North Sumatra, we know there are special economic zone, yeah, in Semangke, held by PTPN3, yeah, our government-owned company, PTPN3 lah in Indonesia in bahasa. So Semangke Special Economic Zone dedicated to host like factory, yeah, in to process, yeah, like the derivative of CPO product, maybe like I don't know how to say fractional fraction, how to process CPO become how to say minyak goreng, ya. And also how to process maybe the kernel of the CPO, the kernel, yeah, PKO Indonesia in PKO, yeah. And there are factory, yeah. Unilever has built one factory in Semangke. So I think in the future, Semangke Special Economic Zone will grow, because North Sumatra and also Riau province, there are so many palm oil mill in this province. So Semangke will become the host to support factory. Investor can build factory in this area, and then they can process the derivative product of CPO. Thank you, Professor. Your presentation is so interesting for me and also maybe for all the participants. Now, it is a question and answer section. So to all participants, you can make question to our presenter, to Mr. Ambarita. You can type your question in the chat room. I will read the question and inform Mr. Ambarita about the question. So, okay, let the participant make question. Okay, while we waiting for the question from participant, I want to discuss with Mr. Ambarita. We know from your presentation that the market share of Indonesian palm oil in the world is about 61%. So this is a huge number. And we know that in every factory or in every palm oil mill, yeah, so they still produce waste from the palm nut shell and also from the mesocarp fiber. Yeah. So another pihak ketiga, the third party can buy this waste, palm nut shell and also mesocarp fiber, because the calorie of this waste is very high. We can compare it with the coal, I think. So based on your experience, why there are still why there are not so many company interesting to use this waste become the produce to energy? Can you share with us based on your experience? Thank you, sir.
Yeah. That's a good question, Mr. Sembiring. I also, because in this today keynote speaker from Sweden, I don't know her name. Yeah, because this is very, 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 I don't know how I say, confused. Why? Every people, I think, in this country agree that palm oil has big potential. Agree, 100%. Even the government already put it in the document. We have to reach this target. Why this is not success? I study about that, but in my opinion, I think we have too much hope in this industry, but the PLN, infrastructure and management, I think it's not. They are in the different objective. Why I say like that? Because in this industry, even though we said the potential is very big, but it is, how I say, one place to another place, it is very huge. Can you imagine if one factory in here can only produce, let's say, 3 megawatt, and then 12,000 hectare again, so long from that, let's say 3 megawatt. 3 megawatt for PLN is nothing. They want to make business with company with 100 megawatt. So I think doesn't meet. It's like because you want to sell electricity to PLN, you have to make so many license. Izin usaha, so many license. I don't think so. People from the plantation want to make that document, because for them the money from 3 megawatt is nothing also. Because it's better for them how to produce more CPO, because for them this is only waste. Yeah, this only was, they don't want to put many, how I say, many effort on that. Especially PLN, because if PLN said, our grid is 5 kilometers from your factory. Yeah, please build grid line to that. Of course, the industry don't want to build it. So still so many conflict. Yeah, so many conflict. And what I see in here about the waste to energy, I think in the past 10 years, the regulation I think already changed 3 times, more than 3 times. Yeah, change. The last regulation, we call it fill-in tariff. They make the same regulation for all renewables. Yeah, from biogas waste, similar to hydro, similar to geothermal. Yes, and sometimes it is conflict. So I found so many problems. Because electricity in Indonesia, it's not like, how I say, it is like national, I mean, business, yeah. It's not so easy to sell electricity to PLN. It's not that easy. So many regulation, and I don't think so. The company, I mean, the plantation enterprise, yeah, want to do that. For them, this is only garbage. So I think we have to sit together. What should we do together? Or maybe, yeah, maybe. Why don't we ask technology from the coal, like Mr. Ari, gasification? Don't sell electricity, just sell gas. Yeah, because business with PLN, it's very hard for them. Never made. Okay, that's my opinion, but I have to.
Thank you, sir. There are any interesting in the waste produced by palm oil mill? We know that the empty fruit buns,
Yeah.
we can process it by using some kind of microba, and then using some technology, and then it can produce methane gas, and we can use the methane gas as a fuel. So how about it? Have you have experience with this technology to using the waste from empty fruit buns, and then using technology like microba, and then it can produce methane gas, something like that? Thank you, sir.
Okay. Let me point one key point in here. I think technology is no problem in here. Technology is not problem. Yeah. The thing is how to make this business become economically. That's only. So about your question, yeah, I hear about that, to make microba from the empty fruit branch. But I think if we want to use that to make gas, it will be very expensive. It's better to trade it, become, how I say, pellet. Yeah, pelleting the empty fruit buns to make it like, how I say, other biomass energy source, not make it into gas. So pome, yes, pome, it's better to convert it into biogas. Yeah. So what I can see in here, the technology is no problem in here anymore. It's no problem, but still the problem is because it is very still expensive, and also sometimes, yeah, we have to build another infrastructure to connect it to the grid. That's the problem in here.
Okay, thank you, sir. So again, to all the participants, you can type your question in the chat room. You can make question to our presenter, so we can continue our discussion about the presentation from Mr. Ambarita.
Can I join the discussion?
Okay.
Mr. Moderator.
Yeah, it's okay, sir.
Yeah, Professor Himsar, this interesting topics, yeah. And in some points, the situation is just similar with the situation in coal mining, because not all of the coal mining can build a CFPP, because the problem is always the grid system, because the PLN, well, the location of mining is coal mining, especially, is in a remote area, and there is no grid from electricity grid from PLN. So it always the problem is how can we sell if the company builds CFPP, then how can they sell the electricity to the PLN? I think that's the similar problem, the analog problem. Even though in palm oil industry, the electricity generation is just small. I mean, 3 megawatt is not it's nothing, as you said, Professor. Some years ago, one of my students in master's level also studied about the electricity generation from the what do you call it? She called it cangkang.
Oh yeah.
Kelapa sawit, yeah. And the economic, if the power plant is built in the area, in the palm oil area, the economic value of the electricity generating from cangkang, from palm oil, is, I think, is quite good. But if you want to sell it to the PLN, then that's the big question about the economic value. My question is I think you have a slide showing that the plantation, the palm oil plantation, what do you call it, palm mill, needs so many kiloliters of fuels, I think. Of fuels. And this is to operate the plant, and also as a for fuel consumption for various equipment. Is it possible if the plantation, the palm oil plant or mill, using electricity instead of diesel, instead of BBM lah, in the solar cell, diesel? Is it possible? Because if it is possible, then maybe part of the electricity generated from the cangkang can be used in the processing of palm oil itself. Like here in south of the Bandung, the textile industries use they use batubara also, they use coal also, and they have CFPP for about 5 megawatt, and they use it as in the process of industries, textile industries, and also I think almost 5 megawatt is used for the textile industries. I think just the remaining, maybe less than 1 megawatt, is they share it to the communities. Is it possible in the palm oil plantation to do like that? I mean,
can I answer directly, Pak Joni Sembiring?
Yeah, okay, you can answer directly. So.
Thank you, Pak Ari. I think in this case we have the same problem, coal and also mill. About your question, it is true, but there is some function can be use the electricity from the mill, because like in my presentation, as I said, there is a power generation in the mill, but the objective of power generation, there are two objectives. One, to produce steam for the process, and the other one, to produce the steam to generate electricity. So if the palm oil mill operated in 24 hours, the electricity can go to the estate. It's for housing and everything. Yeah. But if the the mill or the power generation off, they have to produce electricity by using diesel or sometimes from PLN. So there is a trick in here. If there is no fruit, they will not operate the power generation. So when the electricity come, they have to put supply, like for genset, to support the electricity need to the area. So depend on, of course, they cannot operate the mill only to produce electricity. No, because it is a big power plant actually. So that is the challenge in here. That's why, because they need still diesel to power electricity generator. So that is one thing. Yeah. So the best thing to that is still to connect it to the PLN. But sometimes there is no grid in the mill. There is no grid. So that's why they still need diesel. For example, if a day, one day, let's say 24 hours, if the factory only operate in 12 hours, so they have to produce electricity by using diesel oil. In the next,
excuse me, Mr. Ambarita. I think time is up.
Yeah. Oh.
Maybe we can continue
And
discussion.
the last thing.
Okay,
about the truck. Of course, the truck still they need truck to transport the empty fruit bun to the mill. So cannot zero. Okay, thank you, Pak Sembiring.
Thank you, Professor Ambarita,
Thank you,
and also Dr. Wibowo. Very interesting to see you. Yeah, but time allocation is already we have but the time is not available anymore. So we must go to the next section.
Okay.
Yeah. So we start by presenting from Miss Fuji Lestari, because we get technical problem here. So to Miss Fuji Lestari, you can start your presentation. The time allocation is about 15 minutes. Thank you.
Okay, thank you, sir. Oke, Assalamualaikum warahmatullahi wabarakatuh. Yeah. Good afternoon, Mr. Johnny Sembiring as our moderator here, and good afternoon for Mr. Aryo Wibowo. I'm Fuji Lestari Menestika from Mining Engineering, ITB. Today I will present our research about rare earth element, study of rare earth element potential in acid mine drainage from coal mine. Actually, I submit this paper in SSA categories, but then a committee pushed me to this room to conventional fossil and energy. And maybe my topic is different from another presenter. Okay, we start outline presentation today is a first introduction and then overview about rare earth element and method, and then result and discussion. We know that acid mine drainage or AMD is significant environmental impact of coal activities. This issue is increasingly important because if AMD, if not managed correctly, it will become a burden in the post-mining phase as long as the three elements that make up AMD are still present. AMD can leach side materials, causing an increase in dissolved heavy metals, including RAA. Rare earth elements, including yttrium, are essential raw material for modern technology application. Its most important use include the manufacture of permanent magnets for wind turbines, alloy for rechargeable batteries and jet engines, and phosphorus light-emitting compounds for plasma, liquid crystals, or light-emitting diodes. And the combination of scarce supply and high demand has encouraged various studies to evaluate alternative RAA resources. We know today RAA supply is come from China for 77%, and the second one is from USA. And then various studies state that the coal source and coal-related materials such as coal refuse, coal fly ash, and coal mine drainage, RAA is found with low concentration in large quantity. This is making the RAA study at AMD is high value and very interesting. In Zhang Wenchai, why RAA from coal-related material is interesting? It is because first one is coal-related material contain more HRAA, high RAA, and critical RAA relative to light RAA. Mining costs are negligible because RAA produced as byproduct, so there's no mining cost, transport cost. And then RAA recovery from coal material has the potential to mitigate or eliminate legacy environmental issues. Legacy environment issues, especially AMD. AMD can occur after a post-mining phase. And then enriched RAA in Aceh, in AMD can be one of the RAA resource, but further and site-specific studies are needed. The natural process that produces AMD is expected to continue for centuries or thousands of years without investment in energy. Therefore, this can be considered a renewable resource of RAA. Although efforts to develop the technology and circuits needed to extract them economically have not been sufficient. And the objective this study is to determine the number, the characteristics, and the enrichment RAA in AMD. This is an overview about rare earth elements. Rare earth element is a group of metal elements belonging to the transition group or the lanthanide chemical group, plus scandium and yttrium. There are 15 lanthanide and 2 elements from group 3B. And this is classification for RAA. There are light RAA, medium RAA, and high RAA. And economically, they are classified to three class, critical, uncritical, and excessive. Critical RAA is the most used RAA for technology and have a high price. This is used for RAA. RAA is most used for the green energy and and modern technologies. And how about RAA from coal and coal byproduct? In coal, RAA is found in metal matter and the residual ash from coal combustion at the PLTU, we called. And study of abundance RAA in coal basin is total RAA in the world coal is 62 ppm. In the US coal is 60 ppm. And in Indonesia, there are studies about RAA in coal. There is in Bangkok file it's 120 ppm. And in fly ash from the coal, we know can include RAA. Coal ash in the world is with total RAA for 404 microgram per gram. In Indonesia, coal ash from PLTU Ambilin is studied by Pak Suganal is 169 ppm in fly ash and 64 ppm in bottom ash. But this RAA is not all elements, just cerium, yttrium, lanthanum, neodymium, and samarium. And how about in acid mine drainage in this topic? In Iberian Pirite belt is average total RAA is 2.3 milligram per liter, and in China in Stai coal mine is the average is 61.2 microgram per gram. In Indonesia, studied by Badu Rahman in PTBA tambang Muara Tiga Besar mine is about 15 to 15 until 261 milligram per liter. Acid mine drainage is acidic water in mining or excavation activities. Has high acidity. It is a result of oxidation of sulfide minerals accompanied by the presence of water. The main components of AMD are sulfide minerals, air, and water. The presence of RAA in AMD is mainly due to this dissolution of RAA carrying species under acidic condition created by the natural oxidation of sulfide minerals, mainly pyrite. When exposed to nature, oxidized pyrite undergoes the following reaction. Pyrite meets oxygen and water become ion of ferric and sulfate, and then ion hydrogen. And then pyrite meets ion ferro and meet with water. There are ion ferrite, sulfate, and ion hydrogen. And then the last reaction is when ion ferric meet with oxygen and water become FeOH, or we call yellow boys. This is the data about values RAA in coal mine, in AMD, in coal mine from Indonesia, in India, and China. This is with average is in Indonesia, in Asam coal mine is have high value, then from China and Bukit Asam. This is a graphic about RAA value normalized NASC, Sithai coal mine, and from Jaintia Hill coal field, and Indonesia from PTBA, Bukit Asam. This method, we are collected sample from mine sump. There are 5 samples, and then we do physically test it to the water, and the parameter is pH, temperature, TDS, and EC, electric conductivity. And then Our sample were analyzed for RAA by ICP-MS and ion chromatography or IC to determine the ions. And then water quality, we use paper diagram to know about species, aquatic and water types. This is the data about for 5 samples, S1, S2, S3, S5, and S4 and S5. The low pH is in the S3. And then TDS, the highest TDS is S5. And the ion, minor ions and cation ions. Now, this is a RAA concentration from the 5 samples. The highest total RAA from the sample is come from S4 with 617 microgram per liter. This is the color S4 have high highest cerium, and the sample S2 have the lowest RAA. We do percent correlation coefficient to know correlation between parameters on IMD with RAA. This is parameters. The correlation is EC is have a strong negative correlation with pH, TDS2, and then we will look RAA with those parameters. RAA have strong negative correlation with ion K, and then with ion nitrate. This is an enrichment pattern for RAA. The picture above is enrichment pattern RAA from Bukit Asam, and in the below picture is from Asam-Asam. And the calculation is IMD has high acidity with metal concentration of sulfate, iron sulfate, Fa and Mn. RAA on AMD for Asam-Asam was higher compared to RAA on IMD from Bukit Asam. The concentration of total RAA in Asam-Asam has a strong negative correlation with the concentration of iron nitrate, iron kalium, and iron calcium. In contrast, in Bukit Asam, it has strong positive correlation with pH, Fa, and sulfate. RAA and AMD from Asam-Asam also show the type of medium RAA enrichment for all samples, as is the pattern of RAA enrichment at AMD from Bukit Asam. Okay, thank you.
Yeah, let us give applause to Ms. Fuji Lestari. Thank you, Ms. Fuji.
Thank you. Yes, thank you.
Thanks for the presentation, titling Study of Rare Earth Elements Potential in Acid Mine Drainage from Coal Mine, a case study. Okay, because we are running out in time, so let us continue to second oral presenter, to Ms. Nadila Dina. Welcome back. You can start your presentation. Thank you.
Okay, thank you. Yes. Share. Okay. So good afternoon again, ladies and gentlemen. Can you see my screen or listening to me? Did you get it first? Okay, thanks. So let me continue. The topic I will discuss today is about natural gas transportation business contribution to Indonesia's national energy policy and carbon emission offset by on-grid solar PV utilization in Surabaya, East Java, Indonesia. Yeah. So Pertamina Gas is a company who focuses in midstream sector and downstream of gas industry in Indonesia. Pertamina Gas is part of Indonesia's gas holding, owned by PT Perusahaan Gas Negara and part of PT Pertamina Persero that manage gas trading, gas transportation, gas process, and gas distribution, and other business who has related to with natural gas inheritance products. And in Pertamina Gas, it has 7 operation areas, which is one of them is in East Java operation area. So what we do here, we operate a gas pipeline from the subsea pipeline and also onshore pipeline, approximately over 400 kilometers in total. And the natural gas that we transport there, 44% is for the fertilizer and 22% for power plant and other industries for 24%, and below 0.001% is for city gas. So what I'm gonna tell here is the ultimate purpose for oil and gas business, as in stipulated in Law 22 year 2001 on oil and gas. It's all about create job opportunities and even ultimately maintain the preservation of living environment. To make you in the context, so we would like to comply and even beyond the regulation and policy, one from the corporate sustainability policy, because PT Pertamina Gas has a vision and mission on the sustainability of its business and also the environmental protection as well. And we also involve and or contribute to doing the environmental good practices by comply or even beyond compliance from ministry regulation of environment and forestry, or we can call it proper. Maybe all of you know about proper because most of oil and gas companies also do the proper every year. And last, contribution to government regulation number 79 is all about national energy policy. And the case study here to evaluate the possibility of natural gas infrastructure sector into the contribution on renewable energy initiative. So related to the other policies and the regulation that given before. And what we do here, the implemented project evaluation. So we have the project that has implemented in our office area in East Java, and we want to evaluate is it the project related really can it align to the policy and regulation and the data monitoring, because we have the actual data and also economic analysis, also the environmental benefit. So when we do the case study, we also took a look on the prior works. So we chose the grid-connected system because the intermittency challenges could be solved by the grid-connected. And in other part of the Java or in Indonesia, also use the on-grid PV rooftop design and installation in their industry estate. And also the current study, we're in the design of on-grid PV rooftop in Surabaya as well, but in smaller cap city, it also discussed about how it benefits the user. And here is the evaluation. Why we choose here at the first. So like I said before, Pertamina Gas has several operations areas, but most of them not in a very optimal location for the solar irradiation. So in our office in Surabaya, we have 4,075 kilowatt hour per meter square per day, and comparatively effective due to the average in Indonesia, because in Indonesia have 4,800 kilowatt hour per meter square, as you can see in the picture as well, because it has color there. So what we have here, policy and regulation alignment. Okay. So it is a beyond compliance implementation for energy efficiency and emission reduction aspect from the Ministry Regulation of Environment and Forestry about proper or corporate environmental assessment program. And second contribution to national energy policy for the energy improvement. And last but not least, the contribution to NDC, as maybe in the first session also discussed, the 29% emission reduction by 2030. So here's the chart, our current national energy mix by 2019. It has 9%, but our government has an ambitious goal on the energy mix. It's 23% by 2025. So we have 5 years remaining, and I think every parties could contribute on this goal. So our project firstly initiated in 2018 in
Excuse me, Ms.
third
Dina, 2
quarter.
minutes more.
Yeah.
Sorry.
Oh,
2
okay,
minutes
okay.
more, thank you.
Okay, and the result for the implementation is 2%, our energy mix from new and renewable energy. And this is the design. We have grid connected, and also the performance. We have the actual performance with comparing to the design or the simulation, it's 4% below. So it's quite impressive. And also we have the comparison comparative case, and our local community, they have the export-import scheme, and also the economic analysis. We have the investment here, and our avoided electricity costs from 1 year actual production. So this is the assumption for the economic analysis. And we have here the payback period is in year 15, and also the NPV is beyond 0. And also the LCOE here, simple calculation on LCOE, and it's under the LCOE in or BPP in East Java. So here the final evaluation is environmental benefit, because we could avoid it around 3.3% in the actual year on grid, the state-owned utility. So we can avoid 6.52 tons CO2, or we can say we can offset our carbon from coal-fired power plant. So in one study, it says that it is a very low GHG emission in its life cycle on the renewable technology. So yeah, that's what we have, 2% of renewable energy, and we have the actual production and also the investment that have the 15 years payback period. And also we could offset the ton of CO2. And I think it's all here now. So thank you very much for the time. Hopefully it could give you some insight on what the natural gas or fossil fuel company can do to have a better energy mix profile to contribute to the national energy policy. Thank you.
Yeah, thank you, Ms. Dina. And then we continue to the third oral presenter, to Mr. Eddie Sewandono. You can start your presentation. Thank you.
Thank you, Mr. Johnny Sembiring. Good afternoon,
Yep.
ladies and gentlemen. Mr. Johnny. I'm from Jakarta, University of Indonesia, study at International Strategic Studies Global. And I just want to present my article regarding fossil fuel supply and demand in Indonesia context. Can you see my presentation? Okay, good. Thank you. Okay. Sorry. We have an abstract here. So energy has a strategic contribution to the economic development of the countries due to COVID-19 that disrupts the demand and supply of fossil fuel energy products. So the result is 12.9% of oil fuel consumption decrease, 10.8% gas use decline, 0.9 LPG gas consumption rose, and electricity pour also decline, and the coal consumption also reduced. So consequently, the reduction in fossil fuel energy will be very beneficially for dependency on import, which cause a lot of budget deficits, also potentially decreasing intensity and elasticity of energy, then finally fulfill sustainability energy. Indonesia in energy mix, based on the government target, we have 23% target, yeah, energy mix by 2025, yeah, and 31% by 2050. Meanwhile, in 2025, energy consumption is estimated at 170.8 million ton or oil equivalent, and around 548.8 MTOA in 2050. Until now, 2019, the new national renewable energy mix has only reached 9.15%. So the large use of fossil fuel energy will hamper the achievement of energy mix, so that it cannot increase the value of sustainability. So also difficult to get the target in 2025. It is a fact, yeah. So we see the fossil fuel energy supply fact. There is energy elasticity about 1.08. This is inelastic to GDP per capita, yeah, gross domestic product. So energy intensity level of primary energy was report 3.53 billion a barrel oil equivalent per capita. The intensity of final energy consumption per capita result increase in trend, yeah. So this is bad, yeah, for the energy fossil fuel consumption. And the result from a sustainable development goal index from German is like a consultant for UNDP and United Nations. They gave us index score was 65.3, global rank 101. Yeah, it's bad also. Consists of population with access to electricity 98.1. It's okay in 2017. Population with access to clean fuels and technology for cooking 58.4% is bad, yeah. So energy related carbon dioxide emission 1.7 ton CO2 per capita. It's also not good, yeah. So the high value of elasticity indicates that GDP growth still depends on large energy consumption growth, especially fossil fuel, yeah. High intensity indicate use of energy less efficiently, but energy consumption per capita in Indonesia is relatively low because some consumer is in capital city, yeah, not in the urban city. And the next, this is the energy consumption based on national energy data, ENERDATA 2020. So in crude oil also, we have production big, but the trade is 10.9, yeah, billion ton. And oil product also, we have 54, but the trade 90.6, the consumption is 80. So we have a lot of import here. So about natural gas also 66, we trade minus 20.4 and consumption 40. Coal lignite also, we have a lot of coal lignite, but we export to China and India. Electricity, we have 279 terawatt hour. This 2% is from Asia, yeah, from Asia. We are only 2% contribute. So consumption 245 terawatt hour. So based on this report, the total energy production is 501 million ton oil equivalent. Is 11% from Asia growth, yeah, and minus 235 million ton oil equivalent. It means the trade we import a lot of energy, yeah. So the rest is 269 million ton of oil equivalent, 4% from Asia. So this is a consumption. It is 100, only 11% renewable energy. The rest is fossil fuel. The big from consumption here is transportation and also industry and commerce during a normal condition, yeah. And this during pandemic, yeah, we calculate based on the optimistic scenario. Based on this method, we have a result that in 2018 to 2019, all consumption, yeah, increase, yeah. But during pandemic, there is a decrease, a lot of decrease, around 11%, yeah, 11%. Transportation, commercial, only household you have a trend increase, yeah. The rest is also decrease. So this is the result, yeah. Based on calculation, optimistic 11%, moderate 15.7%, pessimistic 20.5%. When compared as a business as usual, will increase by average of 3.9%. Nominal demand decrease range from 107 until 199 MBOA. The COVID-19 pandemic will also reduce the energy supply. Optimistic 8.3, moderate 11.4, pessimistic 14.4. This also data also coming from PPPT. Yeah. So this is conclusion. Yeah. Based on the condition, the impact of COVID-19 pandemic can be seen from the two economic points of view: the demand side and supply side. This is the supply chain theory, with from the demand side, the condition of the COVID-19 pandemic has reduced the consumption of energy when transportation and business activities restricted, as well as industrial and commercial activities restriction. On the supply side, it is likely to occur contraction in worker productivity, decreased operation and logistic activities, and finally disruption of national supply chains, including energy supply chains. This according to PSBB, semi-lockdown policy. So the decrease in energy demand hopefully is not as significant as the potential decrease in supply chains and potential losses. However, the reduction in fossil fuel energy use will be very beneficial for dependency on import, which cause a lot of budget deficit. This IPBN, yeah, before it suffer, now, yeah, increase, yeah, not increase. I mean, the decrease is not deep, yeah. So also potentially decreasing intensity and elasticity of energy, then finally fulfill sustainability energy. The COVID-19 outbreak also have never been classified before in uncertainty in theory of supply chains. Only like major disruption, another not pandemic, but like national disaster. And now we can categorize pandemic as uncertainty supply chains. So suggestion, the last Pak Joni, every forecasting of aggregate energy demand is fully dependent on assumption create about the increased consumption of fossil fuel energy. Demand forecast updating is required by all members of supply chains, including the producent, also the transportation, all members in supply chains, to increase the further upstream a company is in our supply chains. What the present condition highlight to us is the urgency of reacting time lags. The time lag is an issue, big issue in supply chain, which ultimately affect the slow accumulated demand to update forecasts. However, the significant swing in demand and supply could result in irreversible bullwhip effect that poses challenge to companies to prepare for future ramp up during recovery. So bullwhip effect theory we can use in this situation. Authors suggest that fossil fuel energy producing company estimate their market demands quickly and accurately, as well as improve inventory efficiency and optimize production costs. The author also recommends that renewable energy producer enhance their production. Also, enhance their production. Also, they make the price affordable, and recommends the government to provide incentive to renewable energy producer and accelerate the absorption of renewable energy in order to support the renewable energy business ecosystem easily. And finally, facilitate user access to achieve sustainable energy as soon as possible. Thank you very much, Pak Joni.
Yeah.
Ladies and gentlemen.
Thank you for the presentation, Mr. Edi Swandono.
Yeah.
And
welcome.
Yeah, and finally, we have completed all the tasks for this session. So I thank you all for attending this wonderful conference. Yeah. So now let's take a break, I think. Yeah? Break. So we will meet again in 4:20 p.m., I think. Yeah. And the moderator will be continue with Miss Dian, yeah? Mr. Dian. So goodbye, everyone. Yeah. Let's take our break and see you in the next event. Thank you.
Assalamualaikum.
Waalaikumsalam.
Maaf ini pakai bahasa dulu ya. Ini sudah di room 2 ya?
Sudah, Pak. Pak.
Sudah ya? Okay, good afternoon everyone. Hope you always be healthy. Welcome to the session of 2. Welcome to the session 2 of the parallel oral presentation. Introduce my name Dian Morfi Nasution as moderator in room 2 on the theme of new and renewable energy. As information for the presenter, the time given is 20 minutes, consisting of 15 minutes for presentation and 5 minutes for question and answer. Okay, let's just get started. For the first paper entitled Effect of Ambient Temperature Organic Rankine Cycle Geothermal Power Plant with Aspen Plus. with authors Himsar Ambarita, Martianus Sinaga, and Sihombing. Who will be presenting here?
Thank you for moderator. I will take this chance.
Okay. Go ahead.
Thank you. Good afternoon, everybody. Thank you for this time. My name is Arjuna Hasanto Surya. I come from Universitas Sumatera Utara. The study concerns a thermodynamic analysis of the organic Rankine cycle for energy conversion, with the title Effect of Ambient Temperature Organic Rankine Cycle Geothermal Power Plant with Aspen Place. Okay, the content. The first is introduction. The second is modeling. The third is numerical model. The fourth is table. The fifth is result. And the last is conclusions. Today, based on increase of people widely in the world has impact for electricity. Until today, much of the world energy is produced by burning fossil fuel such as oil, coal, and gas. They are the main cause of global warming, which is causing serious damage to the environment. People need to find the alternative energy like renewable energy source. The energy must safe, sustainable, and environmental friendly source of power production. The organic Rankine cycle, or ORC, is a promising process for the conversion of low and medium temperature heat to electricity. In this present work, this paper reports a thermodynamics analysis of ORC application for generating energy by exploiting geothermal resources. Results are carried out for variance of ambient temperature on power generating of organic Rankine cycle. We can see the model at this slide. In this slide, the modeling of the thermodynamic diagram and Aspen plus schematic modeling. We can see the pump, evaporator, turbine, and condenser. With the work in stage 1 to stage 2, and the process stage 2 to stage 3 with Q in, and stage 3 in stage 1 to stage 2 in the pump, and stage 2 in stage 3 in the evaporator, and stage 3 to stage 4 in the turbine, and stage 4 until stage 1 in the condenser. Okay, numerical models are built up by some parameters approach. The working fluids and their physical properties are implemented by this formula. You can see where V is smaller volume and coefficient are expressed as report below. As we see, and at this table we can see the parameter used for cycle simulation model with working fluid R245 Fa or pentafluoropropane. Mass flow rate of working fluid is 360 kg per horse. Base fraction of working fluid of outlet of pump is 0. Base fraction of working fluid outlet of heat exchanger is 1. Outlet pressure of expander is 5 bar. Geothermal fluid mass flow rate 2000 kilogram per hour. Geothermal fluid temperature is 1000 hour. Sorry, 1000 Celsius degree. And cooling water mass flow rate is 30,000 kilogram per hour. And the cooling water source temperature is a bit among 27, 30, 33, 35, and 40 degrees Celsius. And efficiency turbine is 80% and efficiency pump is 80%. Okay, the result is there are 5. The temperature was simulated to 27 degrees Celsius, 30 degrees Celsius, 33 degrees Celsius, 35 degrees Celsius, and 40 degrees Celsius as ambient temperature to obtain the highest electricity output. And obtain the effect of variance of ambient temperature and operating condition on are analyzed. We can see in this flowchart. This flowchart from the Aspen Plus, from start from pump to evaporator, and the hot in is from geothermal, is Q in from geothermal in evaporator, is this system like heat exchanger, and after from evaporator go to the turbine. From turbine is produce the work to rotate the generator, and the fluoropentan move with this chart from with this diagram. Okay, thermodynamic cycle from figure shows a representation of the thermodynamics. We can see the thermodynamic diagram from TS diagram. Thermodynamic cycle from figure shows a representation of the thermodynamic cycle of the system under investigation in the temperature entropy chart. Then it is compressed by pump itself as subcooled liquid make increase the pressure at the pump, but low temperature, and the pentan enter the evaporator, and with hot steam from geothermal hitting the pentan to increase the temperature of the pentan, and cold steam through back to underground. Is give out, and then the steam with high temperature and pressure enter to the turbine, high temperature and pressure, and generate the generator to get the electricity. Okay, we can see in this graphic from the many temperature with this variable 28 have the more power, and the second is 30, and the third is at 32 degrees Celsius. And if the ambient temperature is high, so the power is less. We can see in this graphic. Okay, that brings us to the end of this presentation. I like to summarize by saying conclusion. The conclusion is the ORC to generate the electricity was simulated and analyzed in this study. Aspen Plus V10 software simulation was used to calculate the thermodynamic characteristic of the design. On the study simulate the variance of ambient temperature from 27 degrees Celsius, 30 degrees Celsius, 33 degrees Celsius, 35 degrees Celsius, and 40 degrees Celsius. And we can see the good condition is in the 27 degrees Celsius. And the third, the system obtained for the R245 FA or pentafluoropropane as working fluid. From this research, so the ambient temperature has affected for power generate of OFC. The lower ambient temperature then will increase the power generate of the system. So at this study, we can see the 27 degrees Celsius is better from another variety temperature. Okay, that's all. I sincerely appreciate your attention today. Thank you. Thank you. And back to the moderator.
Okay. Thank you, Mr. Arjuna. Very good topic. Please, for those who ask, if any question, please. Any question?
Nothing, sir.
Nothing? Mr. Arjuna?
Yes, sir.
I want to ask you, will the results of this modeling be tested experimentally? Will the result of this modeling be tested experimentally?
For this study, we just only simulate at the Aspen place, and with
Only
data.
simulated.
Yes, but from for the data is from the geothermal data. So from the simulation,
not be test experiment.
no, sir.
Okay.
Maybe this can be the suggestion for the geothermal power plant.
Okay. Thank you, Mr. Arjuna. Have a nice day.
Thank you, sir.
Next, the second paper is with code NRE 2025 with the title Performance Analysis of an Improved Solar Dryer with Hybrid System, with authors Himsar Ambarita, Andy M. Romauli, and Sihombing. Is the presenter ready?
Yes, I'm ready, sir. Yes, I'm ready.
Okay. Go ahead.
Sir, I cannot share screen because host disabled participant share screen sharing.
Okay.
Share. I cannot share screen because host disabled participant share screen.
Please send your file to me via chat.
Messenger. Wait a minute.
Can we wait a minute?
Okay, please, Mr. Kasa.
Thank you for this time. Okay, good afternoon, everyone. What a beautiful is. I'm so happy to share this to all of you. Let me first introduce myself. My name is Kasan Asdina Debdeb. I'm student of Mechanical Engineering of Sumatera Utara. So I will share you about performance analysis improved solar dryer with hybrid system. Okay, next. Okay, di sini, I have 5 content. The first, introduction, solution method, result and discussion, and the last one, conclusion. Next. Okay, the use of solar energy in drying is becoming an important and viable alternative, such in decreases consumption of conventional energy. Based on BMKG research, average temperature in Indonesia is 27 to 30 degrees Celsius. This is important for Indonesia to increase productivity. Many benefits utilize the solar dryer radiation for drying. Using a solar dryer, the dryer time can be shortened by about 65% compared to the open sun drying. Solar dryer make the farmer commodity a superior quality. The commodity to be dried is the ginger. The solar dryer hybrid system was designed and compared with a conventional solar collector dryer. Moisture content, weight, lower, and the voltage of the photovoltaic. Next. Okay, next. Kenapa dia? Next. Sir, can you next slide? Okay. The experimental was done and colleagues of engineering department University of Sumatera Utara. The raw material used in this study is red ginger. The total 1 kilogram of red ginger and divide into 2 solar dryer systems. We can see the material conventional solar collector and solar collector hybrid system. We can see the conventional solar collector not use blower fan and photovoltaic, but the solar collector hybrid system use all of material. Okay, next the slide. Okay, this picture we can see the schematic diagram of the complete experimental setup. You can see the collector, this fan blower, and drying box, and the last for record date, it's data logger and hobo. Okay, next the slide. Okay, the experimental runs for compact drying for conventional dryer system and solar dryer hybrid system of red ginger. Pure red ginger was cut into 2 to 3 millimeter slice and then placed on drying tray and dryer. Its dryer solar collector conventional and hybrid system drying press has 0.4 kilogram weight of fresh red ginger. Before starting an experimental run, the whole apparatus was operated for at least 1 hour to stabilize the air temperature and air velocity in dryer. Okay, next slide. Okay, this picture, we can see the experimental setup of conventional solar dryer and solar collector hybrid. We can see in right part solar dryer conventional system and the left part solar dryer hybrid system. Okay, next slide. Okay, in measurement, throughout in the drying process, moisture content was calculated with difference at time interval 30 minutes. The moisture content was calculated on dry base follows initial moisture content and initial sample weight minus final sample weight per initial sample weight. So the PV system and considered as a source of electricity to operate the DC fan. The total energy consumption by the fan is taken as input source of energy. The power output of PV module is given by P electric current and electrical voltage. Okay, next. And the result and discussion show the performance of solar dryer hybrid system is quite different from the solar dryer conventional system. So the result indicate the photovoltaic power output and the module temperature were directly proportional to insolation and ambient temperature. The specification of photovoltaic was shown in the table. You can see the table. Red maximum power is 10 watts power, and the voltage at maximum power is 17.5 volt. And we can see the current of maximum power 0.571 ampere. And the maximum system voltage is 1000. Okay, the pass of slide. Okay, in experimental drying rate, in this research, at last PV become generate power electricity. To running the blower, duration become one of the main factor from this research. You can see the record by Hobo. Picture 3. So during this drying period, the average of solar radiation was 268.40 watt per meter square, and the highest global solar radiation was 533.1 watt per meter square. Okay, next. Okay, in figure 3, we can see the graph, the compression temperature and humidity on the box solar dryer collector conventional. The drying temperature and humidity were varied depend the solar radiation. In figure 3 and figure 4, we showed the compression, the temperature and humidity on the box dryer of solar dryer collector hybrid and solar collector conventional. The average temperature and humidity on the box solar dryer collector conventional was 43.35 degrees Celsius and 42.6%. Well, the average of temperature and humidity on the box solar dryer collector hybrid was 50.05 degrees Celsius and 35.9%. You can see the graph. This is figure 3. And next. Next slide, please. And then this is figure 4. This graph, the compression temperature and humidity on the box solar dryer collector hybrid. So we can see the significant difference of solar dryer collector conventional and solar dryer collector hybrid system was the humidity both system. With the hybrid system, the humidity called decreased 15%. That collector conventional. And from figure 3, the temperature and humidity on solar hybrid system more stable than solar dryer conventional. Effect of the radiation, ambient temperature as inlet temperature collector, and wind velocity made the temperature and humidity on the box solar dryer increase and decrease. That's figure 3 and figure 4. We know the difference. Okay, next slide. Okay, this graph, we can see the figure 6, monster rate of red ginger, solar collector dryer conventional system and solar dryer hybrid system versus time. Okay, figure 6 shows the decrease of monster rate both system versus time. It was dried to the final monster content of 10% from 81%. Effect of the blower from solar dryer hybrid system making time dryer more short. The time drying need a solar drying hybrid system has faster 10% than solar dryer collector conventional. Okay, next. And the last one, and in conclusion, the solar dryer of flat plate collector was contracted. The drying performance was compared among a solar dryer collector conventional and solar dryer collector hybrid system. Use of photovoltaic as energy source for blower to generate forced convection make the drying process faster. With the hybrid system, the humidity on box solar dryer decreased 15%. The result of the current study is beneficial to increase the drying performance of the solar dryer in the future. That's it my presentation. Thanks for attention. That's it.
Okay, thank you, Mr. Kasa. A very good topic too. Please, if anyone want to ask, any question, please. No question? We have 7 minutes. No question? Okay, Mr. Kasa, may I ask you?
Yes, sir.
Is this your thesis or your scriptsy?
Yeah, that's my. I have this. I have maybe not my final project. That's the other paper from my doping. That's my teacher.
Oh, is Prof Himsar Ambarita your supervisor?
Yes, from Insarambarita.
Okay, Mr. Kasa, thanks for your participation. See you next time.
Okay.
Uh,
Thanks. See you, sir.
Next, the third paper is with code NRE 2026 with the title Improvement of Thermal Performance of the Fin Tube Flat Plate Solar Water Heater, with the authors Himsar Ambarita, Eko Yohanes Setiawan, and Sihombing. Is the presenters ready?
Yes, ready, sir.
What's your name?
My name is Horace Siagian, sir.
Okay, Mr. Horace Sotardo Siagian, please go ahead.
Okay, thank you, sir. Okay, good afternoon, everybody. Before I start my presentation, let me introduce myself. My name is Horace Sotardo Siagian. I came from Mechanical Engineering, University of Sumatera Utara. So let me explain my presentation. So the title is Improvement of Thermal Performance of Fin Tube Flat Plate Solar Water Heater. Okay. Content is, the first is introduction, the second is method, third is result, and the last is conclusion. So the first is introduction. Nowadays, each part of the world strives to find renewable energy resource for survival. So exploration of solar energy one of the solution for some problems with energy resource. Today, solar water heater has been showing a significant impact on development technology in many countries. This matter making an investigation about solar water heater continue development. Therefore, in this research, the collector to be tested to improve the efficiency of water heaters is the addition of fins on the surface of tube pipes in the flow of water, where the fins on the pipe are useful to accelerate the rate of heat transfer to the water. So, for the method, this is for thermal analysis of the solar air heater. The main concern of the thermal performance of solar water heater is the heat transfer process within. So the energy gained by the collector can be calculated by using this formula. This is useful heat transfer rate is equal is incoming solar radiation available minus losses incurred from the overall collector. So for the experimental setup, it was constructed as shown in figure 2. The experimental performance of the solar water heater was focused to measure collector outlet hot water temperature and solar irradiance power available during sunny hours. So the solar collector having dimension 1.6 meter times 1.1 meters. In this research, a solar water heater collector was tested with a capacity of 120 liters of water. The design of the collector there is a tube pipe with fin, absorber, transparent cover glass, and insulation on the collector. The fin tube pipe manufactured using a copper sheet of 1 millimeter thickness with a spacing of fin 12 centimeter. The total fin used was 234 pitches installed along the tube pipe. So the total length of the tube pipe is 2,397 centimeter. So the mass flow rate of the system is 0.040 watt kilogram per second. Okay. So for the result and discussion, the experimental was done on August 22 at Medan, Indonesia. And an experiment started at 8 a.m. to 4 p.m. So figure 3 show the variation of solar water radiation and temperature of the ambient of the solar water heater. It is clear from the figure that the two temperatures and solar radiation increase with time, well, from the afternoon toward evening. Okay, so the collector efficiency in the section on the figure 4 shows the efficiency of solar water heater collector during the experiment. It showed the highest collector efficiency occur at the 40 at the time 40 at the time 1054. This is the highest efficiency collector is obtained by 86.28%. And then the tank temperature in the figure 5 shows that the temperature at the flat plate absorber and water versus time during the sunshine hours available at the 8 p.m. to 4 p.m. So we can see this graph. The higher temperature of the flat absorber was 73.14 at the 13:15. Yes. And the water temperature was 49.84 degrees Celsius at the 13:30 WIP. High and low temperature effect by irradiance stroke into collector. From this research showed that the Turing fin for the tube solar water heater can be solution to improve the temperature outlet of the solar water heater. So for the last conclusion, the tube pipe with fin solar water heater showed that the temperatures would increase parallel with the enhancement of global solar irradiation during sunshine hours available. The efficiency of the two-fin flat plate water heater was obtained at 86.28%. This research showed that the use of fin tube solar water heater can be solution to improve the temperature outlet of the solar water heater. Okay, this is my presentation. Thank you. Thank you. Okay.
Okay,
Okay.
thank you, Mr. Horace. An interesting topic. Please, if anyone want to ask. Any questions for this paper? Mr. Kasa, Mr. Arjuna, Mr. Edi.
I know
No
this paper,
question?
sir. I know this paper, sir. And I don't have a question because I know this paper.
Okay, please. Mr. Horace,
Yes, sir.
is this your scriptsy?
Nothing, sir. Not, sir.
That's a project, sir.
Yeah. This is project from Prof. Himsar.
Prof. Himsar is your supervisor?
Yes, sir. With
What's your
Arjuna and
topic? What your topic?
for my project.
Yes,
Oh,
your project.
my final project is simulation about the evaporation salt water, sir. Simulation using ANSYS Fluent. Yes. To see the evaporation occur, the evaporation. This is,
Okay, Mr. Horace.
yes.
Thanks for your participation.
Welcome, sir.
Finally, the fourth paper with code NRE 2020 2027 with the title Geometry Aspects Review of the Natural Circulation System as Innovation in Passive Cooling of Nuclear Reactor, with the authors Dwi Haryanto, Sidik Permana, and Supriyadi from the Institute Teknologi Bandung. Who will present it?
I am Dwi Haryanto.
Okay, Mr. Dwi Haryanto. Please go ahead.
Okay, for the co-host, please my file because I cannot share the screen. Okay, yeah, thank you. Okay, you can set so. Here, this is my file. Okay, thank you for this chance. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam. Okay, in this occasion, I would like to tell you about our research that is about the geometry aspect review of the natural circulation system as innovation in passive cooling of nuclear reactor. My name is Dwi Haryanto. Actually, I'm doctoral student in Institute of Technology Bandung and lecturer in Institute of Technology Sumatera. And my supervisor is Dr. Ang Sidik Permana and Professor Dr. Supriyadi. Okay, next for the next slide. Yeah, next slide, please. Hello. Hello. Okay. Yeah. Let's get to the introduction. What is the natural circulation? Yeah. Natural circulation is a type of heat transfer in fluid medium where fluid flow is generated by a difference in fluid density due to temperature gradients. Okay. Natural circulation system is the system consists of the heat transfer, heat source, and a cooler with pipes connecting them in such way to form a continuous circulation path. Natural circulation is applied in many technological applications such as a solar heater, energy conversion, air circulation of mainly traditional houses, thermal control of the electronic component, and definitely in nuclear power plant. Okay, next. Okay, next. Here is the evolution of nuclear power plant in the world over time. Starting from generation 1, this is early prototypes, and then next to generation 2, this is the commercial power plant. And then go to generation 3, that is advanced light water reactor that have been used in the world. And until now, generation 3 plus that have been again to develop better process safety actually, and such as application of natural circulation, like in advanced piezo water reactor have been applied natural circulation as passive safety. And now is the generation 4. Generation 4 is safer, sustainable, economical, more proliferation resistant, and physically secure. One of the advanced nuclear reactor, generation 4, that have been applied natural circulation is the molten salt reactor. Okay, next. Yeah, natural circulation has become an interesting topic, especially after nuclear incident in March 2011 at Fukushima Daiichi, Japan. In this case, there was a failure of an active cooling device due to a lack of electricity supply that occurred as a result of earthquake and tsunami. Motivated by this, the safety of nuclear power plants with the use of passive safety features such as natural circulation has become a method that has been developed and applied. Lately, the natural circulation system is being studied extensively by many researchers, especially on the instability side, because the natural circulation system is probably more unstable than the active circulation system. Okay, next. Yeah, this is our related works that have been published. First one in International Journal of Electrical Engineering. We try to study the effect of variation in the horizontal width of the loops on the performance of single-phase natural circulation experimentally. And then the second one in International Journal of Energy Research, we try to examine experimentally and simulation the effect of the loop geometry on the natural circulation based cooling system of a given power source. So in the study presented, I'm to review a new natural circulation based passive cooling system in the geometry aspects of the loop based on the result obtained by the author, also to increase the simulation result so that it can approach the experimental result that have been carried. Okay, next. Okay, this is our research method. We have been used computational fluid dynamic model and COMSOL multiphysics software to model the effect of loop geometry on the natural circulation system. In this case, COMSOL multiphysics software was used to solve the governing differential equation. First, the mass conservation equation, Navier-Stokes momentum equation, and two-dimensional heat transfer dynamic equation. For the buoyancy effect in the momentum equation, in the equation B, was set using Bosniak approximation, and then where beta is the coefficient of the thermal expansion at constant pressure. So we can look the gradient of the temperature make a difference density in the Bosniak approximation. Okay, next. Yeah, this is our result. First, the left side is the experimental apparatus with horizontal width of 50 centimeters that have been published in International Journal of Energy Research. And we try to model with COMSOL multiphysics software, like the right hand side. We try to measure the temperature and the flow rate. Okay, next. Yeah, this is the constant and parameter input of COMSOL multiphysics. There is the ready, and then length of heater, and then the characteristic of the loop actually. Yeah, next. Okay, next. Okay, we attach the result and tell a natural circulation simulation result using COMSOL multiphysics, and the left side is the simulation result in the paper, in our paper in International Journal of Energy Research, and the right side is the conducted simulation result. So in the conducted simulation result, we try to consider the conductivity of the pipe. So we can look the conducted simulation show the better appropriate to the experimental result than before, because we including the conductivity of pipe material in calculation. So including the conductivity of pipe material in calculation needs to be considered in modeling the natural circulation loop. We can look the result obtained have suspect stability in the initial minutes. Yeah, we can look the peak in the initial minutes. There is showing the several temperature peaks. Yeah, due to the sudden temperature rise in the modeling. Yeah. Okay, next. Yeah, after modeling the previous work, we use the parameter obtained to model the effect of geometry on the natural circulation system, characteristic in the loop stainless steel pipe. So in the previous work, we use polyvinyl chloride or PVC pipe, and then in the simulation we try to using stainless steel pipe. We can look with constant, we can look the constant height 100 centimeter and the width variation in the website in the picture A. This is the width variation. We can look the width variation has no significant effect on the fluid flow rate, but we can look the wider the loop, the lower the fluid flow rate. And in picture B, with constant width of 50 centimeter and the height variation, we get the head variation has a significant effect on the fluid flow rate. The head doubling of the loop increase the flow rate. Next. Okay. Now, this is the temperature distribution of simulation result over time. Using COMSOL multiphysics. We can look at the initial condition. Heat transfer occurs between the heater wall and water that show with red color in the bottom. This show the heat transfer occur between the heater and wall and water. And then in time 260, we can look the water temperature in the pipe connecting the top of the heater and the cooler increase. And then time 500, simultaneously low temperature water enters the heater. Low temperature water enters the heater. And then high temperature water enters the cooler, and the water temperature gradually returns homogeneous. Okay, we can look the pipe material. Why need to consider? Because pipe material contribute to heat transfer in the fluid, like show in look at time 1800 and in the right hand side. Okay, next. Yeah, we try to get the correlation with molten salt reactor. This is my supervisor and my senior work, and that has been published. This is the correlation of fluid flow rate at molten salt reactor to the number of total power produced by neutron precursor. We can look the full flow rate decrease. If the full flow rate decrease, the power generated by the neutron precursor increase exponentially. Therefore, removing residual decay heat by natural circulation in the absence of power is a crucial safety aspect. Yeah, we can go to conclusion. Next, please. Next, please. Yeah. We can go to the conclusion. Yeah. The conclusion. Sorry, the conclusion. Before this slide, the conclusion. Yeah, thank you. So we get the conclusion. COMSOL multiphysics simulation with input parameter values based on the experimental research and considering the pipe material's conductivity provided some sufficient result for validation. And then we get the direction of fluid flow counterclockwise is indicated by an increase in temperature starting with the above of the heater, then followed by the above and under the cooler, and finally the under of the heater. So we can get the correlation with between heat transfer and the fluid flow rate. And then the flow rate decreased due to the doubling of horizontal length and increased significantly due to doubling of vertical length. And the last, the optimization of loop geometry in the design of the natural circulation system of advanced nuclear reactor is fundamental to enhance passive safety aspect. Yeah, next please. Next please. Next please. Yeah, before this slide, the future work. Okay, thank you. Now, this is our future work because I'm doctoral student. So we have the future work to considering the molten salt as the working fluid to further study the further study the thermal behavior of natural circulation loop, especially in the advanced nuclear reactor, namely the molten salt reactor, and with performing an accident scan by removing cooler when natural circulation occurred to study intensively regarding the instability behavior. Okay, I think that's all about my presentation. Thank you.
Thank you, Mr. Dwi.
Yeah.
Very good research.
Yeah, thank you.
Is this your dissertation?
Yeah, actually, this is from my thesis, and then I will try to continue because this is the first, how to say, tahap pertama in the doctoral
Okay.
first stage in my doctoral student program.
This is a preliminary study.
Yeah, like that.
Yes. Will the simulation results be tested experimental?
Yeah, actually in the thesis, yeah, and then we have been published in International Journal of Energy Research. We have been conducted the experimental, but in the present study, we try to improve the simulation with considering the conductivity of pipe material. Like that.
Okay. What the different COMSOL multiphysics with CFD?
Yeah, actually, COMSOL multiphysics is more friendly user, I think. Yeah, friendly user. But in COMSOL multiphysics, solve the equation based on finite element method. And then I think in the future study, we hope we can simulation with Fluent actually.
Okay.
And then we can get the comparison between the COMSOL multiphysics and then N Fluent.
Fluent. Yeah. Okay, please, if anyone want to ask, Mr. Kasa, Mr. Arjuna, Mr. Horace. Okay, thanks for your presentation, Mr.
Nothing, sir.
Okay.
Sir, I have an question.
Okay.
So this is the experimental or the from simulation for Dwi Haryanto?
Yeah, thank you for the question. Yeah, actually, in the present study, we just simulation, but we got the data from previous experimental. Actually, we have conducted the experimental, but in the present study, we just simulation.
So what software do you use for this study, sir?
Actually, in the study, we use console multiphysics software. Console multiphysics software.
Oh, okay, sir. Thank you.
Okay, Mr. Arjuna.
Yes, sir. You're welcome.
Okay, thanks for your presentation, Mr. Dwi. We pray that your doctoral degree will be achieved quickly.
Yeah.
All right.
Thank you.
All the papers are well presented. All research results are very good and very support in the development of new and renewable energy. And if no one asks, maybe we can end this oral presentation in room 2. Sorry if there is something wrong in the delivery. May we always be healthy, hopefully. And see you later. Please be upon you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. But I want to take your time to take a picture. Please on all participants to open the camera. I will take the picture. Please to all the participants.
Okay, Mr. Farhan.
Okay, to all the participants, please open your cam. I want to take a picture, please. Okay, 1, 2, 3. Okay, thank you everyone.
Thank you, Mr. Farhan.
Thank you.
You're welcome, Mr.